Okay. At the end of class last time, we had established these definitions, okay? N is a multiple of Z, right? So this is a predicate, mult, and the definition of what does it mean for N to be a multiple of Z? Mult N comma Z. That equivalves, there exists an M, which is an integer, range true, such that N equals M times Z, all right? We gave some examples of that last time. And here is the definition of even. What does it mean for a number to be even? In other words, why is 10 even? Because what exists? Why is even.10 true? Because what exists?
A number exists where if you multiply it by 2, it gets 10.
And what is that number that exists? 5. So you should think of this. 10 is even because there exists, because 5 exists. Are you with me? Okay, now the next one, we're going to do a couple more. And by the way, these definitions you should know. Okay, if I ask you what's the definition, you should be able to write this down, all right? The next one we're going to do is very similar to mult, but it's not quite the same. It's divides. So here's another example. X divides.
Is that divisible by then?
Yeah. X, yeah. It divides it evenly with no remainder. Sure. Okay. So X divides Y, and now there's a binary infix symbol for this. It's the vertical bar. Okay. So
Range symbol?
well, yeah, it is the range symbol. Kind of. You just have to know by the context which one it is. That's a good point. Okay. So this is written X divides Y. Yeah, that is kind of unfortunate. But anyway, it's written X divides Y. Can be defined formally as the following. Okay, so here it is. It's X divides Y. Now it's going to be very similar to, it's going to be kind of similar with the, okay, so it's kind of similar, the similar idea to the multiple, right? So let me see, what divides what evenly? 6 divides 24. Do you see what I'm saying? 6 divides 24 evenly with no remainder. Do you see what that means? So it's kind of the flip side of a multiple of. So 6 divides 24 if
It's
Why
a
not
factor.
just x equals 0?
You could say it's a factor.
well, but is it there exists or is it for all?
There exists.
Yeah. Okay. So we're going to write it like this.
6 because 4 exists.
There exists, we'll use the symbol V for the dummy variable. Now, but now here's the thing. This is slightly different. So we're going to insist that V is greater than or equal to 0. Okay? Now, body what? So 6 divides 24.
Such that
If
x times v equals 1.
Yes. X times V equals Y. Right? Are you with me?
Why does v have to be positive?
Well, let me show. Yeah, let me give you.
Does it matter what type n?
Because x and y can be whatever they want to be.
Yeah, V is an integer. Yeah, all of this we're assuming integers, right? Okay. Here, let me give you a series of examples here. So 3 divides 15. So is that true or false?
True.
That's true. Now what about this? 3, this is an easy one. 3 divided by 16 equals what?
False.
False. Right? But now what about negative 3 divides 15? According to this definition. Negative 5 divides
False if
15.
V has to be positive.
It's false because V has to be positive. Are you with me? So this turns out to be false.
But why does V have to be positive?
Well, because, this is the definition of divides. This is the mathematical definition of divides, and because it's a definition, it's a what?
Axiom.
It's like an axiom that can't be proved. So this is the standard definition of divides, and so we can't, because it's a definition, we can't argue with, I mean, you can argue, well, the definition should be this or should be that, but I'm just saying this is what the definition. This is the author's definition of divides. Okay. And what about 3 divides negative 15? What is that? Equivalent.
False.
Okay. But what about negative 3 divides negative 15? Yeah, that's true. So now does everybody see, these are examples of that, of this formal definition. Now, actually, there's another way to write this. Can you think of another way to write this? X divides y equals.
Is it if we assign V as a positive integer?
Yeah, and what was that type called? Well, except this is greater than or equal to 0.
Yeah.
Does
It's either Z plus or an, what is it? Is it Z plus?
Yeah.
Okay.
If it has to be positive.
But it can be 0. I think Z plus doesn't include 0, does it?
Z plus doesn't include 0, but this does.
Right, so the counting numbers, natural numbers, right?
Does 5 divide 0? Here, let's do this.
5 divides 0 because 0 exists.
5 divides 0. What does 5 divide 0? According to that, is this true or false? This is a predicate. It's a function that returns true or false. Now this would be true because why? Because V can be 0.
So it'd be a natural number.
Yeah, so another way of writing this is that, another way, yeah, if V is an integer that's forced to be greater than or equal to 0, another way of writing this would be what? There exists a V, but then we could annotate it and we require its type to be what? To be a natural number. And then, range true. Is everybody clear on this? X times V equals Y. All right? So does everybody understand how divides works? Okay? So let's write this over here. This is our third one. So X divides Y equals, there exists a V, range 0 less than or equal to V, body X times V equals Y. Okay, and it's very similar. I mean, notice that it's just very similar to the mult, but it's just slightly, we've got these slight differences. And by the way, we need this for exercise 9.29a. We need to know this for your homework for next time. Okay. Now, one more example. We have even up there. Anyone want to take a shot at this one? Yeah, X is odd. Can be written formally as, so what would odd dot x equivalent?
It's going to be there exists a K.
Okay, so you say there exists a K.
Type integer. Range true.
Yeah, range true, but now what?
It's something like 2 times K minus 1 equals X.
2 times K minus 1.
Yeah, or plus 1.
Yeah.
Either way. Okay, so is everybody clear on that? You guys got that quick. Have you seen this before?
I had to do it in comp sci 1.
2 times k plus 1 equals x. Right? So there has to exist. So tell me, why is 7, no, sorry. Why is 25 odd? So why is 25 odd? Because what exists?
There's a K.
What is it? Because 12 exists.
1 times 2 plus 1.
Because, and 12 times 2 plus 1 is 25. That's why 25 is odd. Is everybody with me on this? So odd dot x, so that's this one. Odd dot x equivals, there exists a k, z, 2 times k plus 1 equals x. Now in this expression, is k bound or free?
Bound.
It's bound. Is x bound or free? It's free. Notice that that's one of these. So this is a function of x. And what is its type? Is this type, the type of any is the same as the type of its what?
Body.
Of its body. And what's the type of the body?
Type of X.
What's the, no, x is an integer. Is this type integer?
No.
I guess not.
Well, what is equals? It's a Boolean. And therefore this is a function that returns what?
True or false?
Type Boolean. And therefore it is a what?
Predicate.
Predicate. Are you with me? So does everybody see that this is a predicate? This is a predicate. These are all predicates. And all these types here are Boolean, right? So these are predicates. Yeah? Okay. Now, don't bowl me over with your enthusiasm. Okay. So, now, here we go. Now comes the words, the word problems. Okay, what we need to be able to do in the same way that when we did propositional calculus, we had to be able to take statements, declarative statements in English that were true or false, and we had to be able to translate them into Boolean expressions, right? And then we can manipulate them, whatever, right? Okay, so now that we're doing predicate calculus, we have the same problem. In other words, when we say things in English, we need to be able to translate them into expressions in the predicate calculus. Are you with me? These predicates.
What's the vertical bar?
Divides. Okay? Yeah, here it is. X divides y written as x divides here. So. Are we good?
Yeah.
Okay. All right. So now here's your key. Here's your key phrases to look for whenever you want to translate a sentence. Here is a list of words that apply to universal quantification. Now, one of the third word there, for all. That's kind of the way I like to say it. Some people say every. Some people say for each. Some people say any. I kind of, whatever your personal preference is, I've been saying for all. But all these other words work the same way. Every, all, for each, and any. There's even there's another word that should be up there, an. An. Or a. All right. So now here. Okay, so who wants to go first? All even integers are multiples of 2. Now, how would you write that? So here's an English sentence. All even integers are multiples of 2. Well, how would you write that?
For all x.
For all, okay, so you claim for all x.
Oh, for all x type z plus.
For all x. No, it doesn't. Well, for all x. For all x,
Body.
range true. Is that what you said?
No.
Oh, no. All even integers.
Yeah, exactly.
Yeah, how do you do that? Now, so now here we have a list over here. We have
X.
range. So you say range even dot x?
Yeah.
Range just has to be a Boolean.
everything where the range becomes true is,
Yeah, okay, and body what?
multiples of two.
Multiples of, so this is for all x,
that-
for all x,
Oh, wow.
x.
So that
Mul-
molts x2
Is it,
using the method.
yeah, so mult n z means n is a multiple of z. So what are we
So
saying?
that
So we were saying
x is a multiple of 2.
x is a multiple of 2. So we would say what?
Mult x2.
Mult, ooh. Is that good? Here, let's see if we got it right. For all x, oh, he even chooses the same dummy. For all x, type z, range even dot x, mult x. Yeah? Now, does everybody see how you do that translation? Are we good? Okay, how about this next one? Every chapter has at least 3 pages. Okay, so we're going to need some more.
For all.
Yeah, hold on. Before we do this, I'm going to have to tell you, I'm going to have to give you some predicates that you can use, like a chapter and pages and stuff like that. So here's another list for you to use in this example. Let's assume that capital chap is a type, okay? Is a set of chapters, okay? And let's say that size.c is a function that returns the number of pages. Is a function that returns the number of pages in, well, the number of pages. Okay?
Chapters is a set of chapters or a chapter?
No, capital C, it's a type. So it's, and what is a type? Tell me what's the definition of a type?
It's a
It's a,
set of values.
yeah, it's a collection of values, right? Are you with me? So in this book, how many chapters are in this book? Somebody know?
You should know.
I don't know. 20, okay? So this for our textbook, chap would be a set of chapters. So it'd be one, oh, I think he starts with chapter 0. So I think it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? That's the set of all the, right? And then size.5 would be the number of pages in chapter 5. Are you with me? Okay. And didn't we do this before? What does this mean? I think we've done this. We've done this one before, haven't we?
Is an element of. Oh, yeah.
Is an element of, right?
What does that mean?
Is an element of. Right?
Yeah, what does that mean?
Well, that means like, so suppose we have this chap. Okay, so suppose we have chap is the numbers, is the collection 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's that collection of values. Then 5 is an element of that chapter, right? So you would say, you would say like this: 5 is an element of chap. Josh, right here. 5 is an element of chap.
Because there is a chapter 5.
Oh, that's it. There's a
Yeah, there is a chapter. Yeah, that's what it's. Yeah, there is a chapter 5. I think the way we did it is we said we did things like this. Is this true? Here, is this true? 2 is an element of z plus. What does that equal?
all right.
That equal is true. This is the way we. And then how about negative 5 is an element of z plus? That equal is what? False. So this, if you consider this an element of to be a function, what is its type?
Boolean.
Well, it returns type Boolean, but how many arguments, because it's an infix operator, right? It's an infix operator. So what is the, well,
It's going to be
this would be like
something,
something
cross
and then
something.
cross, yeah.
Cross some set.
And then arrow Boolean, yeah. Okay? Are you with me? Okay, so using these, okay, so now how would, this is kind of tricky. Now how would you translate? Every chapter has at least 3 pages. Every chapter has at least, every chapter has at least 3 pages. Yeah, is this going to be a for all or there exists?
For all.
It's going to be a for all. Okay, so what do you think?
Every chapter.
For all what? I mean, what do you have to do when you do for all? When you say for all, and then you have to have a what?
A dummy.
A dummy variable.
For all C.
And that'll be lowercase c, right? Because it's a variable. Okay?
For all C,
Okay.
Type
range.
natural.
Types.
Type chat.
Yeah, say it again?
Type chat.
Yeah, type chap. Now that's one way to do it. You could say for all C type chap,
Range true then.
but then range true.
Right.
And now what?
But you only can say for all natural numbers.
Size dot C.
Yeah, well, in a second. Okay.
Size dot C is greater than or equal to 3, right?
Yeah, very good. Now here's another way to do it.
Yeah, it'll be
Okay, so another way to do it is for all C,
all C,
Where C is an element.
where C is an element of chap, size dot 3 is greater than or equal to 3. Yeah? But an alternate way would be this. For all C, size chap, range true, size dot C.
Can you do that?
Size dot C is greater than or equal to 3. This and this are exactly equivalent.
But size function isn't a predicate, right?
Now, oh, I was going to ask you that, and I was going to try to trick you up. But that was a very good observation. Yeah, I forgot to ask. As I was writing this up, I thought, oh, I'm going to ask them if this is a predicate. They're all going to say yes. But it's not, because what does it return? A number. Yeah, it returns a number, not a Boolean.
Trick us with that.
Yeah. Would you have been tricked?
No. Can you use?
Are you smarter than I think you are? Is that what you're saying? Yeah, chap is a type. Capital C chap.
also live chat.
A type is a set.
Can you use any set as a type?
Yes, any collection of values. That's the definition of type.
Unless this is an element.
Are you with me? That's what a type is.
Universally accepted.
And, well, I mean, that's a type for this.
Making your own type.
Yeah. Okay, we're defining. Is everybody clear on this? Does everybody see how this translates? Okay. Now, how about this? How about even integers are multiples of 2?
You do the same way.
Same way as what?
The first word. For all.
Yeah.
Good observation. That's another way of saying the same thing. I mean, if you say all even integers are multiple, that's the same thing as saying when you say even integers, the word all, every, it's kind of like it goes without saying. When you make a statement like that, it's implicitly universally quantified. It's not explicit. It's kind of like implicit in your. Right? And what about this? An even integer. Is this? Oh, it's an. Does that mean there exists one? Does this mean there exists one?
Doesn't it exist?
It means there exists one, but
I don't think. No. Yeah. See.
an even integer is multiple of 2.
Yeah. See, this is why English is really flaky. It's too bad we don't speak in formal methods, right? When you say
Obviously,
and.
all even integers are multiples of 2, so if you say that.
But when you make that statement, it's the same as any.
Any.
Right. And in this case is the same thing as saying any.
I don't get it.
You do get it?
No.
You don't get it.
When I would say like and something is this, I'm saying like one of this.
No, because you're speaking in general. You're not saying.
Let's use a different example.
Okay. So let me say.
Without the even.
Yeah.
That's
Okay.
A dog is a canine.
Yes. A dog. Yeah. A very good one. A dog is a canine.
All
So you're
dogs
saying
Oh,
are
for all dogs, D is range D is a dog,
Yeah,
body
yeah.
D is a canine.
What if it was like not a noun, like something else?
Well, I mean, I don't know, but the point is right here, is that when you say and, you got to be careful because it looks like you're talking about one and therefore it sounds like it exists, but it's not. When you say and, that was a really good example. Like a dog is, yeah, yeah. Are you with me? Are we good? All right, and now just to drive this point home, I put this up on the board once, but I want to do it again. Theorems are implicitly universally quantified. Theorems are implicitly universally quantified. Okay? And for example, when x squared is greater than or equal to 0 is treated as a theorem. Really what we mean is what? We mean for all x, range true, x squared is greater than or equal to 0. Are you with me? And all of those theorems that we did before, is this a theorem? Okay, another example. You know, is this a theorem? Not P and Q equivales, not P or not Q. When we write this down in propositional calculus and treat this as a theorem, really what does this mean? This is at 9.12, right? Implicit universal quantification. What does this mean? What does this mean? It means for all P and Q. Are you with me? Oh, type what? For all P and Q. Type Boolean. Range true, not P and Q equivales, not P or not Q. That's really what that means. As a matter of fact, I've seen some books, and instead of writing it down this way, they have an abbreviation for this, and they put a square, they put square bracket around it. And this square bracket around the whole thing means, so they make it explicit. So they put the square bracket around it to show that this expression is universally quantified and therefore is a theorem.
That's if P is a theorem, then
quantification, exactly. And so, but our author chooses to, to not do that. And it kind of clutters up the thing. So you just have to kind of like know from the context when you write down an expression whether it's a theorem or not. But some people, they want it to be explicit. So if this is a theorem, then they put a square bracket around it to show, oh, this is a theorem. And it's a shorthand for this. Okay. So, but we'll go with the author on this and just leave them. We'll know by the context. Okay, so that is for all. Now, next one is English words for there exists. For existential quantification. Okay? So what do we have here? Exists, some, there are, there is, at least one, for some. Now it's interesting because for some sounds kind of like a plural, right? But it really means for some one.
there are is also a plural.
There are is also plural, but it really means there are one or more.
Right.
So it really is talking about one or more. There, are you with me? When you say there exists, you're not saying how many. You are saying what? At least one, which is one of those phrases. Yeah.
Not all of them, but there are some.
Yeah. All right. So now, what about using these predicates here? Some even integer is divisible by 3. Now, we're not saying all even integers are divisible by 3. We're saying some even integer is divisible by 3. So what would that be?
6.
Yeah, it's like 6. No, I mean, how do we write that statement using? Yeah, you just proved that is true by one giving us one, or existential introduction, whatever. Okay. Okay, so you're saying there exists, so what?
X, type, integer, range, true.
Okay, range true. So some even whoa, range true?
Even dot X.
Oh, my bad.
Okay, you say now it's going to be even dot x?
Yeah.
Body what?
X, or no, X, 3 divides X, right?
Is divisible by. Yeah, 3 divides x. Is that right?
Sure it is.
Let's see. Oh, divisible. Haha. He used this word divisible.
So, I like it.
It's where X. is
X
divisible.
divides.
It's a flip.
Oh, it's a flip.
X is divisible.
Yeah, okay, divisible. So here, we better, yeah, I didn't notice that. So divisible x3. Here, let's do,
Well, aren't they both the same thing?
well, hold on. Divisible x3 equivals what? No, sorry, divisible xy
Equals Y divided X.
equivals y divides x. Yeah. Okay, so I didn't realize he was going to throw another little English word at us like that. Okay. And now how about this? Oh, shoot, I erased those things. There is a chapter with an even number of pages. Now, how did that work with those?
There exists
There exists a what?
something type chap or range chap.
Yeah, there exists a C. There exists a C, and you could either have it be type chap, or you could say range.
Chap. Or
No.
Element. C is an element.
C is an element of chap.
Could you have done that same kind of thing on the last problem? With the even dot x, putting it in the type?
Well, except the problem is we don't have a type for evens. We don't have a symbol. We don't have a symbol here. We don't have a symbol for we don't have a
Alright.
there's not a common symbol for evens.
We
You know what
can
I'm
say type even the same way we say type chap.
Yeah, but then we'd have to define what even is.
Yeah.
I mean,
All even numbers.
yeah, well, yeah. More than one way to skin a cat. Not that highly. I've never seen it done that way, but you could. Okay, but here, let's finish this out. A chapter with an even number of
Okay,
pages.
so there exists a C, where
C,
C is an element of
chap.
body, size dot C.
C.
No.
Oh, even number of
dot
change.
size dot C.
Even.
Dot size dot c.
Yeah, parentheses size dot
Do
C.
you have to use the parentheses in there?
Well, it's when you have when you're doing a function of a function. I mean, yeah, when you're doing a function of
It's
a,
better. It's clear.
it's more clear this way, I think. So whether you use the dot notation or the parentheses. All right? Are we good? Now let me give you another example of switching between English and formal methods. What is the negative of all integers are even? Check this out. What is the negative of, quote, all, now,
Not all integers.
yeah, but watch this. All integers are even. So check this out. So it's not, so watch this. It's not, in English, it's not all integers are even, right?
So it's just all integers even.
So let's formalize this.
Negation
Let's formalize this. It's not
for all x
for all x
type integer
type integer
range true
range true
even dot x.
Now notice that this statement that we're working, well anyway, we're just translating it, right?
And that is true.
Okay, but
You turn that into existential.
yeah, We could turn this into an existential. So what is this equals by, which De Morgan, what is it? It's De Morgan,
Morgan,
Whatever it is.
De Morgan 9.8.
17.
918 B, C,
Yeah,
something.
917.
Not 17, because you have to have,
Well, you can do whatever you want.
17 has to have both negations.
You'll just use
Do you have your equation sheet there? Do you have your equation sheet?
No.
You don't have your
no, I
equation
actually
sheet?
did. I'm on the same page.
Just write 918
C,
something.
19C.
9.18c. Good. So then what's that?
There exists an X.
That's, there exists an x.
Sub Z, range true, not even dot X.
And then how do you return to English?
You say it.
You say every.
There exists
There are-
an integer.
There is an X, type Z, that is not even.
No, well, but don't,
There
yeah.
is an X that is, there is an integer that's not even.
Yeah, or you could use it, any of the, no, not every. No, you wouldn't say every.
At least one.
You would not say,
Oh,
yeah.
right.
Or you could just say some.
At least one X.
I'll pick, you can pick any one of those.
Some
At
integers.
least one
Some-
integer is not even.
At least
Yeah.
one. At least one integer.
Yeah. So, yeah, all of those work. Some integer,
Now, since even and odd are binary,
some integer.
can you say not even and odd?
Well, you know what?
Where's the theorem? Not even.
No, actually, you know what?
Odd.
You could define even that way, and then you could define odd to be not even. So you could say it's not the case that there exists a da-da-da-da. Are you with me?
0 really considered to be an even number.
Yes, 0 is considered to be an even number. Okay, is everybody
It's divisible by 2.
good?
It's divisible by 2.
Okay.
0.
So now, how about this? How about this? Here's another one. How about 9.32? Every senior took one mathematics class and passed one programming class. Every senior took one mathematics class and passed one programming class.
For all. And in the body.
It would be a for all.
It's for all, but then you have.
And I think you would have an and in the body. So now, what are those two classes, are the math class and the programming class, are those two different classes?
Yeah.
Yeah, I think they are. So it's a for all. So what do we have in the for all?
For all.
Oh no, wait, I take
all
that back.
seniors.
For all senior. Ooh, this is going to be.
Our dummy is senior.
You're right. The dummy variable has got to be a student,
Yeah.
right?
Yeah.
So for all
What do you say?
students. So for all.
For all S type student.
Oh, wait a minute. For all
Type C.
Type senior, rather.
for all S.
Type senior.
Range.
Wait. No, a student. For all, S is a student. S is a student, right?
It's a
Every
senior.
senior took one.
No, but in range what?
Senior.
Ah, is it?
Senior dot X.
Senior dot S, yeah?
Sure. That'll work.
Lame.
Now, what about all of those?
Body. They took a math class and they passed a computer class.
Yeah, so who's they? You say they,
S.
body,
So
so,
that.
oh, but if they took took one mathematics class.
There's
So,
a distinction between taking a mathematics class and passing a class. But there isn't.
Oh, that's interesting.
You're saying the definition for taken SC is that they completed SC, where that's not true.
English. Say,
No, took a math, so completed.
say
Taking the mathematics class is the taken, right?
Sure.
And passing the programming class is the past predicate.
class. Okay.
They took it.
Are you with me?
So you take it.
Now how do we,
Taken.
and furthermore, this is body what? Because we already have this for all S.
Taken S comma math dot C. Close parentheses.
Wait, but what is C? Whoa, but what is C? Where did the C come from?
Oh,
It's a free variable.
No, because this doesn't say, no, it says No.
C
C,
is
no,
a
it's not a free
mathematics
variable.
class.
C should not,
From,
there has to what?
another
There has to, what come on, what?
You just have to give it. You have to.
Yeah, you have to have it, but what?
C equals.
No, but what is C? What is C? What is?
C doesn't even have to be in there. We can.
Well, sure it does, because how are you going to say? You're making a statement. You're saying every senior took one mathematics class. What are you saying about that mathematics class?
Math of C.
What are you saying about that mathematics class? What has to?
We're gonna call it C.
No.
Wait.
No. Oh, come on. Ah! That class, what you're saying is that
Oh, this.
class,
There
what?
exists a math class.
Exists.
There exists
for all-
There exists.
There is a math class.
Okay. No, well, no, but that's how you would
So-
formalize it. Are you with me? Are you?
There exists.
Okay.
All C.
For parentheses, for all C. No, not for all. No, does you mean he had to pass every class?
There
No,
exists a
A
C.
class.
It exists. So there exists.
Math.
No, well, you get it.
There exists a C.
There exists a C.
Range math.
Range. Math of C.
Range math, yeah, math
Yeah,
is C.
range
So
math.
C is a math, yeah, range math C. Okay.
Body
Taken.
C.
Well,
Have you taken?
Body
well, taken, how many parameters does taken have?
taken S.
SC.
Yeah.
Okay, SC.
SC.
Okay.
And
And,
there
There
exists
exists
a
a C.
P.
You can call it C as well, can't you?
well, if you have them separate, I mean, you could do this, there's a couple ways to do this. I think the way our author is going to do it here is, I think he does C and C prime. C and C prime and has it in just one exists. You can have the separate exists with the and or, okay. I think you got it. Here. There exists an S, I'm sorry, for all S, senior.S, so that's this, right?
Of senior.
Okay. There exists, and then he does this together, he does
C prime.
C and C prime. So C is one class, C prime is the next class.
True.
Range
Well,
true,
they took that math. But
math.C and taken SC and C is a programming class and pass this. So and.
So
Yeah.
it's not. It wouldn't work if we had math in the range. Math.
No, it would.
It would.
Yeah, I think you can trade. I think you can trade, right? See, now you got trading. Remember how trading works?
Okay.
Because you can trade. Yeah?
Yeah.
So this is not the only way. You could trade. You get
That
this in
makes
different
sense, 'cause All
forms.
the range really does is it says it has to be within this, so that's what and does as well.
You guys are getting this. This is good. Yeah. This is good. Okay. Now, let me see. I was going to do a function. Here's what I think we better do. Do you have your books? Because 9.29 is one of the exercises for Monday,
Monday.
Thursday, I mean. Okay, and so here's some homework hints.
Why would
Yeah, we do.
We can cancel it.
Okay. Now, what does A look? Do you have your book?
No.
Who has a book? Okay, open it up to exercise 9.29A and read it for us.
925.
929.
The natural number 1 is the only natural number that is smaller than positive integer p and divides p. So,
The natural number
that would
1.
be all, right?
Yes.
A
So,
Okay. Oh,
it's the a and the all are
9.29A. So it would be
for all.
for all. I'm going to use the letter D.
Or d, okay, for all d, natural number. So it'll be what is that? N?
of N.
Of n.
Okay.
Range true.
No, not range true. I don't think because it says. So now what?
It's the only natural number that is smaller than positive integer p and divides p. So it has to be smaller than p.
So it has to be smaller than P.
D is
So
less than p in the range.
yes. So 1 less than D less than P. Right?
Wait. You don't. Why do you have? You don't have to have the one because
Yeah, because 1 divides.
it's already a natural number.
Oh, it tells you one. The natural number 1 is the only natural number.
Yes, it's telling you that 1 is the only natural number that means that for all the other ones
Oh, that it's not.
that are not 1, but that are less than p.
Okay.
Are you with me,
Alright.
sports fans?
When did that?
One.
Aren't you a sports fan?
Body
Okay, so now what does it say about that?
divides. It says divides p. It divides.
Yeah, but are we saying that d divides p?
I think we're doing that d is divisible by. So p divides d.
Well, yeah, but no, I don't think it's divides.
It's D divides P.
No, I don't think it is.
It wouldn't make sense the other way around.
It's not p divides d either. Because what does it say? Read it carefully. Read it again for us out loud.
Natural number 1
The natural number 1
is the only natural number that is smaller than
Is-
positive integer p.
Okay, slow down. Is the what?
Only number.
Only one that does what? Divides. It's saying 1 is the only one that divides. Are you with me?
So it's not.
So what we're saying about all the other ones
If they don't do it.
is that they don't divide it.
So let's just say not divide.
Yes, okay, but you were saying, that's not what you were saying before, you were saying
I
divides.
wanted to find out whether it was PD or DP.
Yeah, okay, well, let's do that now. So not what?
D
Divides. Oh, and divides, we could, x divides y, okay? Divides what? dp, right? Okay, now, if you look in the homework, if you look on the web page, it says do not use the predicates. But we just use the predicate. It says that in your final solution, do not use the predicate. So here's what you should do. So what you should do is write it out this way first, and you could just say equals by definition of divides.
Wait, 29 specifically says to translate it into predicate logic.
It does say translated in.
929
So-
says translate following English statements into predicate logic.
Yeah, well, this is predicate logic, but it uses this predicate. So let's substitute in here. So this would be what? This would be for all d
And 1 less than d.
and
less than n.
1 less than d less than p
And then
body.
Body there.
But now, yeah, what does and so this would be not.
Right.
And now the definition of divide. So what is x divides y? What is
There
it?
VP. So there
A V.
exists a V.
There exists a v,
Range 0 is less than or equal to V.
0, oh, sorry, range 0 less than or equal to v,
Body.
So the-
D
Body.
V.
d times v
equals
equals p, paren. So this is what your answer, your final answer would be.
Did you want to simplify that
I need to look
with the Morgan?
It's
Generalize the
optional.
Morgan.
You can use generalize the Morgan and say whatever, if you want.
How is V allowed to equal 0?
Oh, did I say, that should have been,
It is.
it is, yeah, okay, over here, behind you. 5 divides 0 equals true.
0 is divisible by 5. You get 0.
How many times does 0 go into 5?
0 times.
Are you with me?
I was just thinking like something over 0.
Yeah,
No, not how many times 0 goes into
It's
5.
not
How
5
many
times.
times 5 goes into 0.
Yeah.
right, yeah. Okay, now what about,
If it is D times V equals P, then that's 0 equals 0. That means they're both 0. That's 0 over
0 times 5 equals 0.
well, we're not dividing. There's nothing over 0 in any of this. That's why we'd use multiply and not divide whenever we set these definitions up. Are you with me?
Okay, so what's in there is not necessarily what's out there because I'm thinking.
Whoa, what do you mean what's in here is not?
Because
Is v, hold on. Is v a free variable, yes or no?
No, it's bound.
No, but what about y?
It's free.
And what about x?
It's free.
And so notice that they are here, the free variables are here. So this x is this x, and this y is this y.
But are those x's and y's affected by the v?
Oh, this is, what do you mean affected by?
So like if that
This
v,
is stating there exists a v.
right.
X divides y equals there exists a
So
v.
if that v is 0, would not the x and the y both equal 0?
No.
Yeah.
No.
X can equal
The answer is no.
Because
Yeah.
it's a Boolean. It doesn't.
This is a
affect the actual-
Boolean. It's
Why
true or
would that be
false.
zero?
It's true or
Yeah.
false.
So why would that be zero? You're not determining what X and Y are. You're
Exactly. You're determining whether that, yeah. Okay, let's do one more real quick. Read B. Read B. Read 9.
Some integer is larger than 23.
Some integer is larger than 23. So how would you do that?
There exists n types
N
or type z.
type Z.
Range true.
True. Some integer is greater than, this is easy. 23.
N is greater than 23.
Yeah.
Okay.
Yeah. Okay, so you have a whole slew of those. All right? Slew. All right. See you next time.